In this video, you are going to learn about electromotive force, EMF, and internal resistance. Now let us try to recap what we have learned in Ohm's law. We have this circuit, and we are going to make some changes to the circuit in order to learn electromotive force. The first thing you need to know, in Ohm's law circuit, we have a constant wire because we want to study the current flows through it and also the voltage across it. But in this topic, we don't need the constant wire, so we can remove it. So there's no more constant wire. And remember, in this topic also, we are learning about the dry cell. So we need to change the position of voltmeter. Now the voltmeter is across the dry cell. Okay. And you can see we have ammeter, and ammeter is used to measure the current that flows through this dry cell. And this is rheostat, and the rheostat is actually the resistor that we use in the circuit, and we can manipulate the current that flows in the circuit using the rheostat. Okay, now here's the dry cell. Actually, the dry cell here, we can draw something like this. Okay, I'm showing it here. Here's the dry cell. Okay, it is something like this. Okay, this is the EMF in the dry cell. However, in a dry cell, we have electrolyte, and current experiences resistance while flowing through the electrolyte. That's why we have internal resistance in the dry cell. And the symbol we use for internal resistance is small r, and EMF is capital E. So that is the symbol we used. Okay. Now we have variation of current because we have a rheostat here, and then when you do the experiment, you're going to get what is the value for voltage. Now here, look at the switch. The switch is off. This means that current cannot flow. So in this case, the voltmeter is going to measure what is the voltage across battery, and it's going to measure the EMF of the battery. So when you draw a graph, it's going to be the highest value because the energy in the battery itself is not used yet. So when you switch on the circuit, current will start flowing. So when current flows through the rheostat, some of the energy is used so that the charge can flow through the resistor or the rheostat in this case. What happens is the value of the voltage across the dry cell will drop a little bit. So when you increase the resistance here, more energy is needed so that current can pass through the rheostat. So what happens is the voltage across the dry cell will drop more. So you should get a straight line, something like this, and the value of voltage across dry cell will decrease linearly like this. So this is the graph that you should get from this experiment. Now let us try to look at the voltage here. As I told you, we have electromotive force here and we have resistance. The energy comes from the dry cell, or given by the value of EMF here. So E equals to, okay, now we have voltage drop across this external resistor or the rheostat. Let's say the voltage across this is V, and the voltage drop across R is IR. Okay, this one comes from V equals IR, but in this case we use small r because it is internal resistance. Okay, so this is the equation that we can get from this circuit, and we are going to use this equation to find out what is internal resistance. Okay, but in the meantime, you can open the textbook page 114 to find what is the definition for EMF. Now let us look at this graph again. This is what I have mentioned earlier. So we are going to manipulate this equation. Now V equals E minus IR. Okay, so bring this one up to the other side, so you get this equation. And then you can change again, IR, negative IR plus E. And from here you can write negative RI plus E. Okay. Something that you have learned in maths, this is y-axis and this is x-axis, and you can write y equals mx plus c. This is the linear equation, and from here you can tell that EMF is C, and internal resistance is negative. The gradient is the negative internal resistance. So you can write E is V intercept, and internal resistance R is the negative of gradient. It's the negative of gradient. So you can look at examples how to solve the problem using this formula.